Hello, everyone. Molten Corpse proudly presents Genus X, a project that classifies the music genre using machine learning.
Okay, so you might be asking, what is Genus X? Genus X is our machine learning project that classifies music into 10 different genres based on different parameters of a song given. So we used a data set from Kaggle, and it did have a lot of unnecessary information. It included like the date access, which we didn't really need that, as well as the artist name and the track name. So we did not include those in our data set. So we did have to sort of filter out the data set from Kaggle. But other than that, we use the data that was in that data set.
The first visual here is popularity versus tempo. It shows that the tempo is highly responsible for predicting the genre. You could see that by all the clumps of colors shown.
Okay, our second scatter plot was loudness to tempo, and you can notice two major things in there. The first is that as the tempo raises, there is less songs with a bigger tempo, so there's hardly any songs above 200 BPM. And the second major thing you can notice is that the majority of classical music, which is blue dots, is the most quietest music among all the genres, and the loudest one is country, which is a yellow dots, because most of its songs lie between -20 and 0 decibels range, and it is one of the loudest genres. Yeah, probably the most loudest.
And then this 3D scatter plot takes in song duration, loudness, popularity, and energy. And even though there is a lot of overlap, putting more variables into a single plot allows us to see more patterns across the genres.
This heat map shows the correlation between the different variables in each song. Energy and loudness are some of the variables that showed greater correlation than others. Greater correlation makes it easier to find patterns across genres since there are many variables with the correlation close to 0, which results in the computer having difficult comparing many of the song's parameters.
Okay, now we'll talk about the models we used. The first one is called logistic regression, which is a classification algorithm that is used to predict the probability of categorical dependent variable, and it relies on a binary output, which is either 1 or 0 in most of the cases. But in our case, because we're predicting music genres, we have 10 outputs. So for this scenario, we had to implement multi and nominal logistic regression, which works with 3 or more, like 10 in our case. So the pros and cons of a logistic regression, I'm going to just name one of pro and one con. So logistic regression is the most easiest, the most primitive, and it's easier to implement, interpret, and it's very efficient to train. It is one of the most primitive supervised learning machines algorithm. And the con is that it can be used only to predict discrete functions. So basically what it means is that it can be used only to predict classification, and it cannot be used in regression. Even though it is called regression, there's a big story behind it. Why is it called regression? And it only works with classification, but I don't have time to tell it to you now. So we'll go next. So there's the accuracy of a logistic regression. There's a diffusion metrics. As you can see, the most accurate genre is the classical. It has 771 guessed correct, and the least accurate is alternative music, which is 296 guessed correct.
The next model we have is naive Bayes. Naive Bayes uses the Bayes theorem to predict specifically classification models. The math's there if you want to look at that, but I'm just going to list some pros and cons. Good pro is it's a very fast algorithm. Another pro is that it works better with with categorical input compared to numerical input. A con is it assumes all features are independent. This is not accurate in the real world, so that's why it's bad. An application is it's used to detect a spam email or not.
Okay, so the next model that we used were classification trees. So decision trees or classification trees are non-parametric supervised learning methods that are used for classification and regression. So the way that classification trees work is through a process known as binary recursive partitioning, which basically means that it's a repetitive process of splitting data into smaller and smaller pieces to get the tree. So some pros to the classification trees are that they are simple to understand and interpret, and they don't really require much data preparation. And a couple cons are that decision trees can be unstable because of small variations in data. It can result in just different things being generated. And predictions of decision trees aren't very smooth or continuous, so this can cause a couple of issues.
Random forest is a collection of different trees. One that has the highest percentage is used to handle classification tasks for our models. One of the benefits is feature bagging, which also makes the random forest classifier an effective tool for estimating missing values as it maintains accuracy when a portion of the data is missing. One of our challenges was random forest requires more resources since it processes larger data sets and is much bigger to handle.
XGBoost is another supervised machine learning algorithm that usually outperforms other algorithms by using more accurate approximations in order to find the best tree models, but it also usually takes longer to run than other algorithms. In our data, XGBoost still has a difficult time determining the genre of music because of the many overlapping parameters, such as in the bottom row of the heat map, where the model classifies hip hop music as rap more often than it classifies hip hop music correctly. But by messing with the model's parameters through trial and error, we were able to get an accuracy of 66.6%.
So continuing what Ryan was saying about accuracy, we had a bunch of different models just because we wanted to ensure that we got the highest accuracy possible. So that is why we had so many different models. So as you can see, this bar graph shows the difference in accuracy and percentage between each of our models. So logistic regression had an accuracy of 53%, naive Bayes had 42%, classification trees had 44%, random forest had 50%, and logistic regression had 53%, and the highest was XGBoost with 66%. And the reason that these may not seem as high as, like ideal is because we had so many different factors. We had 10 different columns of data of factors that went into our data set that determined the genre overall. So.
Okay, here we have a section with our actual product prediction. Richard has already copy pasted all the values we want to predict the genre for. And if you click submit, you will be shown that the genre of music is electronic. So it predicted that the genre of music, that all the values we inputted for the song is supposed to be electronic song.
All right, so here we have the molten cores team. Me, Richard, as the product manager. Ryan C as the front end, our amazing AI camp instructor Uzair, Naya Pesh, Ryan R, and Ilya M. Lastly, I would like to say great job to everyone who represented and the amazing work that every single one of you guys put in. And that is the end of our project. Thank you all for listening.